we will see, we'll explore the data a bit, and the first step would be to create the MCRPC diagnosis state. So MCRPC diagnosis state is defined as the earliest of metastatic diagnosis date and the CRPC date, castrate-resistant prostate cancer diagnosis date. So this is how we have defined, we have to compute the variable. So first let us explore the data set, the raw data, and then based on them we will see how to compute that particular variable. So let us identify those variables. Here we have metastatic diagnosis date, and here we have CRPC diagnosis date. I just brought it together. Here is metastatic and here is CRPC diagnosis. So whichever is the earliest means before, that is minimum of these two. And if we don't have metastatic diagnosis date, then we have to take the CRPC date. And if we don't have the CRPC date here, then you have to take the metastatic diagnosis date. And if both are available, then we will take the earliest or minimum of the two dates. So that is the concept of MCRPC date, which is the index date. And as we have already discussed what is the index date in the previous video, part 1, attrition table creation part 1. And in this video, we will see how we will compute those variables. Index date, which is the minimum of two variables. So we know what is patient ID. Diagnosis date is the initial diagnosis date of prostate cancer. Metastatic diagnosis date is the date when the prostate cancer was metastasized. That is, it has spread from to different regions of the body. CRPC date, it is the date when it was diagnosed of castrate-resistant prostate cancer. So this again was discussed in the previous video. What is prostate, the difference between prostate cancer and castrate-resistant prostate cancer. Then that is group stage, which is the stage of cancer. We have 1, 2, 3, in that suffix also AB, etc. And then we have T stage. T stage is the tumor size. It tells the size of the tumor, if it is small or big. T1 means small. T higher number of means its tumor size is big. N stage. N stage tells whether the tumor has spread to the lymph nodes. So N0 means not spread. Again, if you have a higher number, it means it has spread. So N1 means it has spread to the lymph nodes. And then we have M stage. M stage is the M0 means not metastasized. The cancer has not spread. M1 means the cancer has spread, metastasized. Histology, if you keeping the prostate cells under the microscope, what we see is histology. Is CRPC, whether the patient is castrate resistant or not. If it is yes, means castrate resistant, it's 1. If the patient is not, then it's 0. Then we have Gleason score. Again, if you look at a higher number, it means the cancer is very aggressive. How aggressive the cancer is, it tells. And then we have PSA diagnosis. PSA is actually a protein, prostate specific antigen, and it's usually higher when the patient is having a prostate cancer. So higher the number, it means it's more advanced PSA levels. And then this is PSA diagnosis at initial diagnosis, and the next one is PSA at met diagnosis. When the patient met metastatic diagnosis, what was the PSA levels? So let's start with the SSMS SQL code. Raw table if X is IDX. So if there is a table, use the hash show, it's a temporary table. And if It's already there. Let's drop it so that otherwise it will throw an error that this table is already there. So in order to avoid that error, we always write the syntax. If a table is already there, we try to drop it. And if it doesn't exist, it's fine. But so we have if condition. If it exists, we drop it. Next, we are looking at patient ID, met diagnosis date, CRPC date. And these are the two variables with which we have to derive the index date. Case when met diagnosis date is not null and CRPC date is not null, then 1, L0 and as MCRPC. So if both are not null, then we flag it as 1. Otherwise, it's 0 for the value of MCRPC. So case when met diagnosis date is null, then CRPC date. On the other hand, if CRPC is null, then we'll take the met diagnosis date. And if met diagnosis date is less than or equal to CRPC date, then we'll take the met diagnosis date because we need the minimum, that is earliest one of the two variables. On the other hand, if it is the other condition, opposite condition, if met diagnosis date is greater than CRPC date, then we'll take the CRPC date. So whichever is minimum we are taking, and as IDX date. So this is how we are computing the earliest value. In this condition, when we are telling met diagnosis date is less than CRPC date, less than or equal to CRPC date, then we are taking met diagnosis date. Here, what if the met diagnosis date is actually missing? Will this be true? No, this condition will not be true because if it is null, then SQL will consider it as unknown. This value will not be considered, will not be true. Therefore, null is not treated as either true or false. It's unknown. So this is how we are computing the IDX state here. And we'll see next one is MCRP equal to latest of the two if both exist. I'm sorry, this is wrong. I just have to delete this part. It's not needed. So next you see we are creating IDX. This is the temporary table we are creating using into. And from this particular data set, this is the where it's the input data is red. This is the new data set, temporary data set that is created. When we say temporary, it means that after we close the session of SSMS, then this particular data sets are no more existing. It will be gone. It is similar to the work library in SAS, if you are familiar with SAS. Step is we are filtering the data, considering that we know that there is a study. The IDX date should be between the start date and the IDX end date, which is the index period. Basically, the start date and the IDX end date define the index period. So this is, we already defined the index period or start date, and this is the second one is the IDX end date. IDX here index actually means. So remember that whenever we are running the code, we have to run it from this point onwards because this stays within the batch. So if I run it separately and then the second time when I run the rest of the code, this will not be executed. This particular values that I have referenced will not be executed. So we have to run it all together until this point. Till we have to run all together. Otherwise, these points, these variables that we initialize, start date, IDX, end date, will run only if we run it all together in one batch, one go. If we don't want to do that, we can just write here, select start date. We can create a data set with those three variables, start date, IDX, end date, and end date that we created here. These three variables we can create in a separate data set, just like I did it here. You can see drop table if exists params. So I created a table here, params table that contains start date, end date, and IDX end date, formatted as date. And I have inserted the values that are same values as here. So now the advantage of this is I don't have to, even if I don't run in batch, it's okay. It will not throw any error. I can just have to write select start between, and then I can write select start date from this particular params, and similarly and IDX end date from there. So this is another approach of doing it. But since I'm running it in one go, I'm referencing it. I'm initializing, I'm referencing it here. Now, if I run this particular table, having filtered between these two dates, the same data set, let's run it and see. And we can see we have created IDX date, which is the earliest of met diagnosed date or CRPC date. So we have 2020 01 25. This one, because this is none, obviously the non-missing value will be taken. And if both are present, we'll take the minimum value that we can see. For example, here 2018 is lesser than 2019. So we have taken the minimum value, earliest date. So this is how we have to create the index date here for this particular study project. In the next video, we will see how to perform the same operation in R and Python and SAS.